So, we, before I throw this on the other screen, we yesterday talked a little bit about this and how we graph points in our parabola. Now, one thing that's interesting when the parabola has been shifted right or left is when you start at 0 and start moving to the right, you want to pay attention to, are my values increasing, decreasing, what's going on? And at some point, it should flip what it's doing. So notice that we're decreasing all the way to here, and we slow down. We decrease by 5, then decrease by 3, then decrease by 1. That's an indication that you're getting closer to the vertex. Because remember, parabolas are steeper the further away from the vertex they are. Their slope levels out the closer they get to the vertex. So then, when I see that this is symmetric, which doesn't always work out that perfect, but there's a change of 1 here and a change of 1 here, this indicates my vertex point. From there, we find our zeros, or if I did this the other way around and I had factored first, we could find the zeros first, and then find our vertex as the average of those 0 points. Calvin?
That parabola doesn't look like it lines up with the points.
Probably because somebody dropped this on here, like using a graphing utility, so they probably couldn't perfectly line it up here. This image is likely from before we had things like Desmos. I grabbed this off the internet because I did not want to spend the time to make my own. Yeah, it's slightly off to the right, but it should line up right here if it was correct. So it's hard to make parabolas on computers look perfect when you're like making it yourself. When you put it in Desmos or something, then it's super easy. So we're going to do a little bit of lesson. We're going to do 12.2, but it's not that big of a lesson. And then I'm going to give you guys time to work on the practice because I kind of anticipated that not everyone would have worked on 12.1. Parabolas are fairly important, so I want to make sure that we get some solid knowledge. So problem 1 here is done out for you. This is when we're looking for the axis of symmetry. So what you want to highlight or notate right here is that we have a specific formula to find our axis of symmetry. The x value of the axis of symmetry will be at negative b over 2a. So b is the coefficient to your x, and of course a is the coefficient to your x squared. So as long as I have the quadratic formula given to me, or not formula, the function given to me, I can find the axis just like this. From there, I can actually work my way outward both directions to graph 2 points on each side, because normally if we have 5 points, it's enough to make the parabola, and then we're good. So we plug in our b value, and the opposite of a negative, of course, is going to end up positive. So we get 3 for my x value. That tells me that my axis is at x equals 3. So then to find the vertex point, what do I do with that x?
Plug it in.
Yeah, just plug it in and find out what your y is. So we plug in our 3 to everywhere we see x. We find out that y is negative 5, which shows me where my vertex is. From there, I guess I should capture before I move on. From there, we plop our vertex down, then take either 1 step or 2 steps in either direction. It doesn't really matter what you decide to do as long as you're just placing points. Because if I place this point 2 away, I know there's the exact same point on the other side. So I could go 1, and here I don't know if this would have been a perfect wind-up point. If they looked at 4, if we plug in 4, we could find out. Then they plug in 5, and they plug in 6, and they reflect those on the opposite side. And that is the easy way to manually graph a parabola with the axis of symmetry found for you. Any questions on that solution process done out? Yeah.
What determines whether it moves left or right?
What do you mean what determines?
What thing in the equation makes it go left or right?
Oh, like where it shifts?
Yeah.
If you don't mind waiting a couple days, we specifically get to that in just a couple days. We don't need... we will get to the point where you can look at a quadratic, you can do a tiny bit of work, and you can immediately say what the shift vertical and what the shift horizontal was. So let's look at the got it here. I think I figured out the issue with my smart board and everything. I just need to shut my computer down every night, by the way. It's working today because I shut it down yesterday. So I want you guys, on your own, first find the axis of symmetry. I know you wouldn't have to, but let's utilize that skill. So write down your formula. X equals negative b over 2a. By the way, this negative b over 2a, does that like remind you of anything? Megan?
What did oh, you wrote negative b. I saw negative 6 for a second.
If it doesn't, that's fine. I'll come back to this in a week or two.
Is it that whole one thing where you could break them up? What's it called?
You sound like Brian.
Yeah.
It was the whole ACB thing. I don't know what it's actually called. Binomial, the binomial thingy, right?
Quadratic?
No.
Thank you!
Is that what it's called?
It's the quadratic formula.
Oh yeah.
So if I can find an image of how this gets used, probably won't, but we'll talk about this next week. But the quadratic formula, here's your negative b, here's your 2a. The only thing that the quadratic formula changes is that in the numerator, we add plus or minus radical b squared minus 4ac. Now, why, hold on, why do we use the quadratic formula? Does anyone know? Because we're not there yet. This is next week, but I'm trying to give you a taste of where we're going. The quadratic formula is not to find your axis of symmetry. It's to find your zeros. So instead of factoring, if I can't factor or I choose not to, I can use this. And here's the other really cool thing. The quadratic formula is in your calculator. Like if you have a graphing calculator, it's in there. Not your iPhone, graphing calculator.
Right.
So, this negative b over 2a. So, I'm going to give you a couple minutes. Solve out where's your axis of symmetry, where's your vertex, and then graph your parabola. Yeah.
Can you sing the quadratic formula song?
Now, I never really learned it as like the
Calvin?
song, but yeah.
Calvin. 1, 2, 3, hit it! X equals LCB plus or minus the square root of b squared minus 4ac all over 2a.
There's a crunch of syllables in there. Minus 4ac, you're like, whatever. Yeah, I like it. Nice. If that helps you remember it, perfect.
Yeah, I know.
X equals b. X equals b.
You guys should be solving this. So you should be solving this. Try to keep your eyes on your paper. I'm going to quietly write some things up here. By the way, in case you see any different notations, saying y equals and saying f of x equals is exactly the same thing. This is saying the function output at point x. This is saying the output. They say the same thing. This is just a little bit more specific. So Rhea, when you went to plug in to find your axis of symmetry, what did you use for A and what did you use for B? You don't know, that's fine. So we're going to remember that all quadratic functions are set up in the form ax squared plus bx plus c, assuming all positive. So if I have a negative coefficient, that makes my a or b value or c value negative. So my b value here is 4, so my numerator becomes the opposite of 4, or negative 4. My a value is negative 1. Now, if there was no negative, it would just be 1, but remember, there's always a coefficient. If you have a variable, there's always a coefficient. So that becomes negative 4 over negative 2, which gives me 2. So my x point, I know my axis of symmetry, and you can go ahead and draw this on your paper, is at x equals 2. And you know I've got an axis that runs there. Now I plug in that x value everywhere that I have an x in my function in order to find the y. Some people will try to screw up here. What happens first? The square or the negative? The square. So this is 4, but negative. So we have negative 4. I'll just jot these down somewhere. Plus 8 minus 2. When we sum it all together, we get 2. So that tells me 2 is my vertex. So that is going to be our maximum. From there, we set up a t-chart. Which way did you go, Megan? Or which way do you want to go? Because, I mean, it's up to us. We choose this.
I started by value of, yeah, and then I just did 0.
So you did 0 as the next point? 0 is always a super easy point. You should always use it, because what is your y at 0? It's just your constant. So at 0, I'm at -2, which I'm also at then 4 -2, because I can reflect. And I need at least one other point. Because my parabola hasn't gone too far yet, I would try to go one more out. And you can either use a negative or use a positive. I kind of prefer positives, but that doesn't make it right or wrong. The advantage to using a negative here is I can use a smaller value. So I could use a positive value if I use 5 or 6 or 7 or 8, but I can use a smaller number if I use like -1 or -2. So choose any of them. Let's just try -1 and see what happens. If I plugged in -1, and again, you can use your graphing utility for this. If you plug this into your calculator, you can then tell it if x equals, tell me what y equals, and we'll do some of that work next week. Because right now we're mainly focusing on manual. So if I plug in -1, well, -1 squared makes 1. The opposite of that is -1. Plus 4 times -1, so that's going to be a -4. And then -2. What do we get? -7. So at -1, I'm at -7. And at 5, I'm at -7. And I can now draw my parabola. And there we go.
Can I ask what you'd actually use this for in real life?
Yeah.
Outside of an engineering career?
In art.
So there's lots of applications to art, even trying to get properly parabolic shapes, like how to look how you want them to.
I mean,
You can use it in modeling, like in a CAD design software or something, to model different shapes depending on what like features it has. If it's not perfectly round, if it's like parabolic as opposed to circular. You can use it when modeling things traveling, or like my brother used to work for a company called Edison Welding Institute, and they do a lot of like how do different metals have to do with what's going on. So even like growth or decay will sometimes be modeled by parabola. So if you like have something in a lab and it's decaying, but it's got a half-life, so like everything that has like carbon dating or things like that has what's called a half-life, where it will half every so many like years or decades or whatever, but it never fully disappears because it halves. So that's like the idea of infinity, right? I go halfway to the door, halfway to the door, halfway to the door. I never make it to the door, but I get infinitely closer to the door. So there's different applications, and that actually we're going to look at some things called limits, where like when you graph something, it would go like this and then like level out almost flat. That's what we call a limit. So that's kind of an application that derives from some parabolic work. And I mean, if you want to go deeper than that, you can Google up like how to use parabolas or parabolas in real life. I mean, there's lots of applications, but most of it has to do with fighting gravity, because objects dealing with gravity make parabolic relationships. Because gravity being -9.8 meters per second squared, or -16 feet per second squared, that starts a parabolic relationship.
What about orbits?
Yeah, because gravity affects that as well. So I don't know specifically the application of it because you just brought it up just like that. But we could probably look up how, like, there are quadratic functions involved in the coding of the programs that have to be involved to keep it where it needs to be, to fight against that gravity and stay in that perfect zone of, like, not outside the orbit gravity, not too close to get sucked in. You got to kind of keep adjusting. So that's like really broad overview of how it would be used. But especially if you decide to go engineering, this is huge. And like, you guys can think you know what you want to do right now. That's probably going to change. Like, it might not. Like, your passion right now could ride you through the rest of your life. But in 8th grade, I forget even what I thought I wanted to be, but I had no idea that I wanted to become a teacher until I really like made it to college.
You just did a career survey.
Did you? How'd that go? Anyone get a career that was really weird? Or did you get your results back yet?
We didn't really get it. I called mine stereotypical. Teacher didn't find it very funny.
I got a good one.
It gave
What?
me a
I got a marine engineer, a petroleum engineer, and a veterinarian. I got anesthesiologist.
Yeah, you can make
I
some
got an
sense.
occupation that I've been thinking about.
What's that?
Marketing.
My sister-in-law is involved in marketing and PR. She just got a job with the Ohio Grocers Association doing their marketing. All right, so another application could be if you want to rig the t-shirt launching. If you want to make sure that your buddy launching the t-shirts is going to get that t-shirt to you, you could model up some parabolas and figure out how far they're going to go. So, this t-shirt... This t-shirt launcher shoots upward at a velocity of 72 feet per second. The t-shirt is caught at 35 feet above the gym floor. How long will it take the t-shirt to reach its maximum height? When we model things dealing with gravity, almost always the x value is our time. So we model this because I've been given feet per second. The gravity that I have to use has to be the negative 16. So this is where you have to be specific, whether it's negative 16 or negative 9.8. What is the other value given to me in? So then, it says t-shirt launched from a height of 5 feet. So C is going to be 5. And it has an initial upward velocity of 72 feet per second. So V is 72. So when we set this up, our height, and actually go ahead and say height at time t. I'm going to change how they write it just a little bit. And yes, you have it on your paper, but we're going to talk about it as we write it. This is why it's quadratic, is gravity is per second per second. The amount of time is exponential. Like, it changes the...
Because it's an acceleration.
Yes.
Not a velocity.
The velocity, though, is a constant. When it starts, is a constant value. So it's 72 feet per second. So every second it would be traveling 72 feet if
Wouldn't that be a T?
if it could maintain, which it can't. You guys in some physics classes up into high school will probably get into situations where you use gravity or don't use gravity. In any perfect situation, there would be no gravity resistance, no air resistance. I could maintain my velocity. Real world, you can't. Like, if you let off the gas pedal, you're slowing down because there's friction on the road. Then, it is launched from 5 feet above the ground. We can figure out when it's at the absolute top of its arc. And yes, it's on your paper. But by finding what point. What point would be the top of the flight of the shirt?
The maximum.
The maximum, which really generally is the vertex to begin with. So if we want to find the vertex, first off, find the x value, or in this case, the t value. So this is asking how long does it take to reach the top of its flight. So when we solve this out, let's plug in our value. So I give you the formula to start, but we got to plug in everything else and solve it out. So, Michelle, what are my b and a values here? Ooh, negative 16. Guys, if you ever get an answer that doesn't look right, Like if you got a negative value for t, in this situation, you can't have a negative time. So that wouldn't make sense. So pay attention to what makes sense in the case that we're working with. So we end up with negative 72 over negative 32. What do we get with that, Calvin?
9/4.
Okay, 9/4, which comes out to be 2.25. We'll go ahead and use fractions because if you were using a watch or a clock or something, you would probably use the decimal. Sorry, we'll use the decimal and avoid the fraction because we don't normally talk about time in fractions. So, then, how high did it actually go? Well, if we plug in the 2.25, and this is the other, like, cool thing that you can do with Desmos. So let me, I might like blow your mind, but this is going to make your life easier. You might just be like, oh yeah, I knew that. But one real easy way that we can use Desmos. If I model this function, let's say y equals negative 16t squared plus 72t plus 5. So if I zoom out, this is where the shirt starts. The y values are your height, and the x values are your time. So if I then make a vertical line at the x value we just found, 2.25 seconds. So to be vertical, I have to be x equals 2.25. Anyone know what I can do now? I can look at my intersect point. There's my y value. I don't need to plug in 2.25 to my function. If I plug in 2.25 to my graph and find out what the y value is there, it's solved out for me. So that then tells me that my y value there will be 86. Leaving. Yeah.
So, this isn't really a math question, but the slingshot says that it's 5 feet, but that's like at all of their head height. So do they just
Well, when you
really
pull
put
it down, right when it starts, right when you let go of it, that would be your initial height.
Because it's right at his face.
Yeah, but if you're going to launch it up, you're pulling that slingshot down. So maybe this was right before the shot or right after they let go. But yeah, it would have been lower. It would have been at 5 feet. So ignore the picture. Now, it asks us, though, what are we actually trying to solve for?
How in the world is people in the front supposed to get?
So we found the max height, right? We found how long it takes. What is the range? Now, what does range correspond to? Right?
How far it goes?
Well, x or y values.
What? No, X. I don't know. Man, you trying.
Think about domain and range compared to x and
I
y.
remember the system.
Right.
Oh, it's Y.
The y values. So my range here, where's the shirt start? 5. Where's the shirt end?
30.
So does it ever go below 5? No, so my range.
No, it's not.
He's still screwed up. Wait, you just say 5 to 35.
How do we know which side of the parabolic arc they catch it on?
So when we start the arc, this point here is initial, right? So the y-intercepts are going to be initial points. So that's start point. So where he catches it at the 35 feet is going to be right here. So if we were able to track what the x value is there, which there's another easy way that I can do this. If you wanted to solve for the x value when your y value was 35, what other function would I set up here? Y equals 35. And then if you find this point, he caught it at 4.035 seconds.
Man, that man's
How
a
do we
big
know he didn't
catcher.
catch it on the way up? Because he.
Because it wouldn't be over the parabola. If you think about where the parabola is,
So they just had it straight
Wait,
at
I
you.
have a question.
Yeah.
How can this might sound like a wait? Now that I think about it, it sounds like a sort of dumb question. But how would this? Why would this be? I guess the math could be done in the parabola, but in like real life, it wouldn't be a parabola.
yeah, what?
What?
Like
It doesn't go like.
No, I know, but now I'm confused because.
So,
oh wait.
this is a parabola,
Yeah.
or this is a parabola.
Oh no, I was thinking they just shot it straight to it.
Even if you shoot it straight,
Yeah.
it's parabolic because of gravity. So if I throw this straight, it still arcs as a parabola.
But we said there wasn't air resistance or gravity.
No, here, like,
Oh yeah, there is.
negative 16 is your gravity. Now, we are ignoring air resistance right now as a negligible effect. So, there is air resistance, but it's not enough to worry about in this case.
Okay.
Wait, wouldn't it negate itself anyways? Because it slows it down as it goes up and as it goes down.
No, how would it negate itself? If it slowed it down both ways, that's going to affect our time.
Well, right, but it wouldn't weigh. It would still be a parabolic arc.
Yeah. But we just don't do the math about the air resistance right here.
Or they shot it straight
I thought it was gonna be like
So,
basically like shot.
Our range for the height in this actual situation would be that 5 is less than or equal to the y value is less than or equal to
35.
86.
86. Now he caught it at 35, but it went all the way up to 86.
So if you had really long arms, you could catch it.
If he was like in Space Jam, where he just like.
Yeah, the stretch thing.
Space Jam.
Yeah, that's what he does. He stretches his arm out.
Try the got it on your own, and then we'll just work on homework. Try the got it on your own, and then we'll work on homework. Hey guys, stop talking about Space Jam. Try this problem. You haven't done last night's homework. Come on. Oh, not mute. Freeze. Well, I'm going to model this in Desmos while you guys are doing that, just to show you how that would work. Don't go over there. Everyone will see it.
Mr. Hudson,
Mm-hmm.
what should we assume the starting height is? Yeah. 5 feet.
Yeah, I just assumed 5 feet.
Yeah.
And you get even numbers.
Yeah, you'd either want to start it at 5, or you'd be saying that your starting point is your 0. So if we're referencing the basketball court, just like we just did, we'd say it starts at 5. Here's the other way also that your graphing calculator is kind of better than Desmos. is that when you're working in Desmos, you can only change the zoom consistently. I can't change my X zoom and my Y zoom differently, so it makes it kind of difficult. Now, one of the other super cool things, give me your attention for a second. What I can do with my functions is I can convert my functions into either being a table or graphing it. I can change the colors. I can't get back to, it just gave me the option for convert to table. So if I convert to table, I can kind of see these values, or I can plug in more values so I can make a table just like you can do in your graphing calculator. So I could say when time is 0, when time is 1, when time is 2, and I can plug all these values in. So I could keep doing when time is 3, when time is 4, when time is 5. Well, now it's already hit the court again, but it can't even do that. I know it's caught at 35, so it's going to be between 3 and 4. So if I wanted to keep getting more specific, I could say, like, okay, what about 3.5 or 3.4? If I get close to it, then I can go try to find it on the graph, or I can just go to the graph to begin with and just click on my point. There's my maximum, 269. But my point where y equals 35, if that's graphed, then I can find my intersection point of 3.4. So let's work out the math for this.
Yeah, I'm kind of.
I got draft.
So we set up, actually let's do h of t. You can do f of t for any function, but if we want to be specific and model height based off time, what's your formula? Negative.
16 t squared.
Sorry, my brain wanted to write the 6 first. Don't know why.
Plus 64 t. Plus 5.
So then, what do we do? Right?
Find the center point.
The axis, yeah. Now this is really easy because I get negative 64 over negative 32 if I can write the right things.
Oh, I just realized.
And it's dose. So like we just saw on the graph, when x is 2, what does y equal? So I can say my height at 2 is going to be negative 16, 2 squared, plus 64 times 2, plus 5.
What's the answer to that?
2 squared is 4, so this would be negative 16 times 4, negative 40, 60, 64, I think. And then plus 128 plus 5,
You get 69.
which is how I get that point.
Yeah, I just looked at the top thing. Now.
So it'll take 2 seconds to reach the max height, and it'll be at a height of 69 feet.
Yep.
Then the range of the function, well, if it's caught at 35, it never gets to 0, so it'd be 5 up to 69, so 5 is less than or equal to y, or h of t, if you want to use that, is less than or equal to 69. Any questions?
How is there any way to like reasonably figure out when it's caught without using an outside program?
Like what time it's caught?
Yeah.
Yeah, for sure. So we could, instead of knowing the time, I don't want to clear all that. So what do we know? You guys can go ahead and work on your homework if you want. What do we know about when it's caught?
It's 18. The height is 35.
It's 35, right? So the height at the time will be 35.
No.
Hey guys, so Calvin asked, is there a way to solve this without using a graphing utility? Like, to find the time when it's caught. So what we know, and you can ignore me if you want, but please don't talk over me, is that it's caught at the height of 35. We don't know what the time is, but this is the h of t, of some t. We know all this based off the given information. If I subtract 5 from both sides, I'm going to get that 30 is equal to negative 16 t squared plus 64t. And this is really funny because you are actually going a step further than we were going to go today. This was more of next week work. So if you start looking at this, I could like factor something out.
16t.
Yeah. So what did we do when we wanted to find x values? When something crossed somewhere? So when we start up here, if I set a 0 over here and start solving this, it finds where my parabola crosses the 0 line, right? So now I've set a 35 here. If I solve, factor this out, I'll find where my parabola crosses the 35 line. But what I want to do before I try to solve this is put it back into quadratic form, which means get it equal to 0. So this can now actually become
What does that do?
sorry, what? Okay, how so? So if we multiply A and C, so do you have that? So if I did 16 times 3, because negative times negative, going to get a positive, but 16 times 3 would be 48. Then I put a 0 on. So my AC is 480. We need factors of that.
I would have factored out a 2 first, so you could deal with
So the other way that we could make these values smaller by factoring what we can first. So they're all even. So I know I can factor out a 2. This can be negative 8t squared plus 32t minus 15. Now I have less factors that can be involved to make that negative 15. Really only 15, 1, or 5, and 3. So this is where I could set up and start playing with it. I'm going to capture so that I can keep working, like move this to the top and keep working. So if I have 2 times negative 8t squared plus 32, sorry, 32t, not 30tt, minus 15. So ignore the 2 out front for a moment. I could do negative 8t and just t, or I could do like negative 4t and a 2t, and then I could do other manipulations of that. So if I think of factors of negative 15, and I know the positive has to win out, so I could do positive 5 and negative 3. Well, that's the net. Well, hold on. If I move this negative over to this t, well, that doesn't help either, because then this becomes positive and that, well, maybe. So if this is actually positive, this is what I mean by play with it sometimes. If you don't know the exact process, sometimes just set up a couple options. What would I get now? My outside, my inside, I get 43t. That one doesn't work out.
It doesn't work. I tried all the integers around that area, and like the closest I can get is 43 and 34.
It's not an integer.
Right.
That's the issue. So this gets harder because it's not an integer value. So can it be done? Yes. Can it be done easily?
No.
Not in this situation. Because the output value is not an integer. So this didn't work out. I don't think that'll work out.
It's between 4 and 5, one of the values. I was doing a thing where you multiply the two on the A and the C, and then
Yeah.
find factors that sum 32. It's somewhere between 4 and 5. And the other
So back up to our negative 16t squared plus 64t minus 30. X equals negative b plus or minus square root
B squared.
b squared, so
Minus
64 squared minus 4 times a times c
How do you remember that?
all over 2 times the a value. That will get your result. You will get one positive and one negative. The positive is the only one that would make sense. If the factoring doesn't work easily, this is when we go use our quadratic. Because remember, this is not modeling the zeros. This is modeling the 35s. Because we changed our quadratic. We are out of time.
Can I take a quick picture of that? little
Sure.
figure right there?
This is gonna be on. So if you didn't notice, there's a new folder in Schoology right at the top of your materials page. It says all completed class notes or completed class notes PDF, something like that. All your notes are going into that folder now. So if it,
Desmos, can we just write on our paper on Desmos?
No.
yeah, but if it asks to graph it, make sure you've got it, like some of the manual graphs shown, so that we can see that you can actually graph it by
All those
hand.
graphics function. Not all of it, like most of them.
Yeah, and we can talk more about that on Tuesday.
So then should we manually graph or should we just do it?